Hello, everyone. Thanks so much for joining us today. My name's Charlotte. I work in the Learning and Development team here at the IMechE. I'm very excited to be introducing today's webinar on building data-centric teams in engineering organisations. We'll be learning more about how to harness the power of AI and data to build a high-performance and data-driven engineering team. Our presenter for today is Ali. He's a chartered engineer here at the IMechE who delivers a number of excellent training courses in our digital and AI suite. If you do have any questions at all today, please just pop them in the chat box and we'll try to answer as many as we can at the end. All right, over to you, Ali.
All right, thank you very much, Charlotte. And welcome everyone to today's webinar on building data-centric teams. My name is Ali Parande. I'm an IMechE associate and a chartered engineer who is a mechanical engineer by background. Transitioned my career into AI and data science a while ago, and have been leading teams both at small startups, rail tech startups, and different consultancies, whether small or large, at multinational consultancies. And I just wanted to bring some of that experience to you today in building some of these data-centric teams, hiring leads as well as seniors and juniors. I have had the experience of being line manager as well as hiring some of these talents and understanding a bit more about the landscape. Additionally, I have been developing some of these training courses here at IMechE. So if you are interested in any of them, you can attend any of these going forward. What I believe in today is that in the future, a lot of the engineers will have additional tools in their toolbox in around using statistics and computers to build AI models so that they can perform predictions and forecasting on these models on their measurement data. So, and the problem with equations is that there normally takes in some assumptions. And with these AI models, you can actually just use your measurement data to capture the patterns in them. And then be able to make predictions and forecast and solve several engineering problems. So in order to do that, I think in the future these engineers will actually be data scientists. So what that means is that they will have expertise in business and domain knowledge and engineering knowledge, as well as background in mathematics and statistics, with additional skills around computer science and digital skills in order to be able to realize all of this in building these models and performing any kind of work that's needed on data sets that they have in these companies. So a lot of potential could be unlocked in the future by utilizing the data that companies have that may be sitting around dormant or sitting around in silos. And once these engineers bring all of these skills together, both in digital skills, in their mathematical skills, as well as from their domain knowledge, there can be many opportunities that can be unlocked both for the economy and in the engineering sectors. We have at IMechE several courses that allows this, that we can provide this training to help with this. So if you're interested in any of these courses, feel free to scan the QR code, which will take you to the training page, which allows you to sign up for any of these courses that is interested to you, if you would be interested in learning how to implement any of these AI tools within your own organizations. But for today's webinar, what we will be focusing on and what the agenda we have is to understand the trends in AI and data landscape, because I know a lot of engineering organizations are interested in this area, especially with the release of tools like ChatGPT and DALL-E that can produce any kind of text and images. There has been a big trend in understanding how AI works and how to actually implement it in organizations. I appreciate the role of data in AI projects and AI project lifecycles, being able to differentiate between these roles. So there is data scientist, data analyst, data engineer, software engineer. So all of these have different roles and responsibilities, but they can be used interchangeably, and that can cause a bit of confusion. An AI project lifecycle is slightly different from normal engineering project lifecycle, so we're going to look at that as well. To be able to differentiate between these data roles, purpose, responsibilities, and skills. The other thing is understanding how these data roles interact. So if you want to hire for any of these roles, you have a better understanding of which ones you need and how to hire any of those talents as you require. There are some talent acquisition mistakes that companies make when it comes to hiring these roles when they're trying to build the data-centric teams. We'll also look at those as well. And hopefully by the end of this webinar, you will have a better, clear understanding of the essential digital upskilling requirements that you may have for your teams, and have a better understanding on how to support your data teams and your engineering teams in delivery of data-driven projects. So if you need to build any kind of data tool, you would be able to have a better understanding of the talent that you need in order to implement and do that going forward. So the first topic we want to look at is the AI and data landscape, and just a bit of understanding behind the AI fundamentals and why we need to build data-centric teams. So as you can tell, there has been a big, massive talk about the AI and data. This is a field that started, since 1990s, but have been gradually growing over time. And just so you could see how fast the field is moving, a venture capital firm has actually visualized the AI, big data and AI landscape in 2012, and they have been doing it every year. And if you just compare the landscape from 2012, all the companies and tools that exist within the field, versus 2023, which is just last year, you can see how fast the field is growing. There has also been a study by Capital Economics for Department of Culture, Media, Sports that have looked at the AI adoption rates in the UK by sector and by business size. So you can see how across a variety of sectors, how AI is currently being adopted. So at least 30% of companies in legal, IT, telecoms, finance, they are starting to try to adopt this. And I think engineering sectors lag a bit behind, but especially in like manufacturing, there has been a lot of movement to try to adopt these technologies. And what they have predicted is that across all business sizes, whether it's small, medium, and large, there's going to be a growing number of percentage of businesses who will be trying to adopt this to stay competitive and be ahead of the game. And essentially those businesses that don't, and they will be falling behind, and they will lose their competitive advantageness. If you just look at the expenditure of labor and technology on AI, you can see that the prediction is as we go towards 2020, 2040, there will be at least a 200,000 essentially number of businesses who will be increasing in across all scenarios, whether downside, central, or upside, who will be spending more in terms of billions of pounds on these tools and these skills. So they will be trying to spend more on AI, and you can see across all scenarios that at least there will be 100 to 200 billion pounds of expenditure going up across all the industries in businesses trying to adopt AI in the UK. So it's a very growing field, and this is where all the markets are moving. So it's essentially very important that engineering organizations can also build their data-centric teams so that they can actually leverage this technology. If we just look at these sectors just by the technology expenditure, we can see that in 2020, which was when this study was done, manufacturing and construction industries actually were the ones to spend the most on labor in terms of billions of pounds. So like manufacturing spent 7 billion pounds, where construction spent 2.1 just on the labor. And the technology normally here is like relevant, whether like they use the cloud tool or they have some kind of like internal company tools that they have spent money on. So you can see there is a lot of like movement and investments in this area across different industries, and actually manufacturing and construction leading the way. To some extent. So it's good that all the other engineering sectors like catch up and get forward with this. And I think one of the blockers of that is shortage of talent. So O'Reilly Media, which is a big tech publisher in tech, have published a study that looked at why companies are not adopting AI as fast as they could. And one of the biggest problems with that is a lack of skilled people. And normally what happens is that the skilled engineers and skilled people who can implement these tools, they normally flock to sectors that pay higher salaries. And one of these problems with this is that some sectors get to have all of the talent and other sectors will have the shortage. So one requirement of that is to essentially upskill internally, or be able to provide more lucrative and more interesting opportunities for these talents so that they can, they can thrive in this sector. So biggest challenges for companies not having adopted AI so far is the fact that there is lack of skilled people to actually, build these tools. The companies don't have access to the data required to build AI. So normally AI requires some form of data to actually build something on top. The other part is normally it's a bit hard to imagine what they can do with AI. So part of this is the understanding of how AI works. So if you understand how it works, you can actually come up with ideas of what you can do in your field. And as we mentioned previously, because not everyone have your domain knowledge, even if you know about AI, you would not be able to come up with these ideas. So the understanding the mathematics behind it, how the technology work, how the computers work, as well as how things work in your market, allow you to come up with these ideas for identifying opportunities that help you innovate in your industry. Other reasons, such as technical infrastructure challenges, company culture, legal concerns, all of it play a field, but it's not as big as the other areas that O'Reilly Media has essentially, like identified as the main big blockers. So if you just look at why this is the case, I think we just got to compare why AI projects are a bit different when we try to implement them versus traditional engineering projects. So if you just map them together side by side, when it comes to AI and data projects, normally they involve a lot of data, whereas with engineering projects, normally it involves like building some kind of physical infrastructure or a physical component. Or perhaps some kind of software. Just the fact that building AI and building data, working with data requires a lot of data sets. It requires a lot of iterative experimentation. So it's more like an R&D project if companies try to adopt AI. So some companies may have, approached this the wrong way. They need to actually design these projects to be more run like agile projects and iterative projects rather than a waterfall project where you plan everything in advance. There is a lot more uncertainty when it comes to AI projects compared to traditional engineering projects. And the approach is that the AI projects are more data driven, whereas engineering projects are more theory driven, and it's driven by existing knowledge bases, which requiring understanding of physical loads and materials. Whereas with approach with AI projects is like you just rely on your data and the patterns in the data, understanding what the data is telling you. And the data we talk about here is more like actual real world field measurement data, because they can capture all the complexities that are happening in the real world scenarios. The competence that's required for AI projects normally is a bit higher than just traditional engineering projects, because you also need to have understanding of statistics, data science, programming languages, and how to handle data, like where to put it in databases, so a little bit of software engineering. And the time frames for AI projects is sometimes flexible because you don't know what you're going to get next week, or you don't know what you're going to get this week. So you constantly need to adjust the timeline compared in relation to the outputs of your current project at the time. And in terms of verification validation, with engineering projects, you have prototyping, you can simulate and test to verify the performance and safety, whereas with AI projects, you may need to do additional work on top in terms of extensive testing and validation of data sets, making sure there is no bias in your data and that the AI models or whatever tools you have produced with AI is actually work the exact requirements that you need. And most of the time, AI tools are not deterministic, so they don't produce results exactly this every time that you run them. Some of the results they produce are more like approximations that can vary, and they have some form of tolerance. So you need to make sure that these outputs is what you expect within your applications. So overall, the AI projects needs to be run, and data projects, AI projects need to be run in more like an agile manner, where you essentially have a very flexible scope, but you play around with the time and the resources to achieve the objectives of the project. So essentially like how you would do an R&D project. Whereas with more traditional engineering projects, the more you can define your project ahead of time, the less you can reduce your risk. The more you can reduce your risk over time. But that means also that like if you decide to change something end of the project, there is a lot more cost. Whereas with agile projects, you can keep changing and you can keep iterating in iterations and keep your costs low whilst advancing in reducing the uncertainty going forward. So because of the way these dynamics work, the data-centric teams and teams that are required to work on AI projects need to work differently, and they do need different forms of they do need different forms of approaching how you run these projects. So to have an understanding of why this is the case, I think it's important to understand how AI works at least a high level. And the main thing is a lot of terms in AI are used interchangeably. Like you may have heard in the news, people talk about AI, they talk about machine learning, they talk about deep learning, and they all may sound similar. The main difference between them is whenever we talk about AI, we talk about any kind of machine that can mimic human behavior. And that's pretty much about it. It's been around since 1950s. And it encompasses everything other than just traditional like the machine learning and deep learning that you have heard today. So computer scientists have been playing around with it, and it's just until recently that computers have become powerful enough that can perform computational mathematics and use statistics to build prediction models. And machine learning, which is a subset of AI, is essentially the main driver of this. So machine learning actually uses statistical mathematics under the hood and computational mathematics to build these AI models. And a subset of machine learning is deep learning, which mostly focuses on neural network-based algorithms. So if you build a prediction model that is using a neural network as the underlying algorithm and mechanism, we call that deep learning. So this is how like AI, machine learning, and deep learning relate to each other. But some people don't understand these relationships and talk about them interchangeably when it comes to hiring or when it comes to actually like trying to implement an AI project. The main difference between a traditional modeling and machine learning is that with traditional modeling, you essentially have some data, you work with that data, and you handcraft the model yourself. You perform some kind of simulation, you handcraft the model, you write some code, and then you give the data and the model to the computer, and then the computer produces a result. So you essentially do the modeling yourself. With machine learning, you have some sample data, and you know what the expected result should be from that sample data. So you have the input, you have the output. You don't know how to go from the input to the output. You give that to an algorithm in the computer. The algorithm then produces you a model. So it's essentially the model is automatically generated from your input data and output data. And then you can use that model on new data sets. So then you can use that model on new data sets to perform new predictions. So that's essentially how traditional modeling and machine learning differ. And understanding the whole process of machine learning and the pitfalls and things like that is where you need talent, because there's a lot of statistics involved, there's a lot of computational mathematics, as well as having an understanding of traditional engineering domain knowledge, which is related to the data that you normally work to day to day. So if someone doesn't understand your measurement data, they cannot build a model on it, even though they understand AI and they understand programming. So it encompasses all of those skills. When we talk about machine learning, there is 3 different types of machine learning. There is supervised learning, unsupervised learning, and reinforcement learning. So supervised learning is essentially working with categorical predictions or with value-based predictions, where you're trying to fit a line through the data. Categorical predictions are called classification, where you're trying to categorize your data points, whereas regression is about fitting a line through your data. And that line could be linear or it could be non-linear. With unsupervised learning, it's about clustering your data points into groups. And with reinforcement learning, it's essentially you don't have a data, but you have like an environment where an AI agent gets trained in. Normally it's used in robotics or in driverless cars. And then from that environment, the agent then becomes starts from a random agent and gets trained and become an expert agent, and they can then perform in similar environments with new different types of challenges. So there is a whole like subfields across different ones, but essentially, when data-centric teams work on building different AI models from top of their data, they are working on one of these type of problems. They are either trying to build a classification model or a regression model or a clustering model or a reinforcement learning model. So one of these models they're trying to build, depending on the problem that they're trying to solve, whether it's a decision-making system they're trying to build, whether it's a forecasting system they're trying to build, or a recommendation system they're trying to build, or a driverless car or like some kind of robotic system they're trying to build. They will choose one of these 4 options. But what makes actually building AI models hard is their ethics and essentially keeping up with their ethics, because all of these components play a part. The bias in the data and the quality issues in the data will make for worse models. The AI models are essentially themselves complex because of the emergent properties of the interactions within their components. If you choose the incorrect evaluation methods, you may end up putting into production a model that actually doesn't work. And people may be using your model, your AI prediction models in the wrong way, whether they're normal engineers or the public. They could be using the models in the wrong way. The technology is advancing really fast. Also, at the same time, you want to race to the market and make sure you remain competitive. So all of these dilemmas and the fact that there aren't any lack of standards, all of these and contribute to making sure that building the right team, you have that team in place, and it makes it hard for existing people, existing talent to sometimes work on these projects, because complying with the ethics of AI can also be hard, especially when it comes to data that doesn't have good quality and they have bias in it, the system complexity, and the fact that there aren't good enough standards yet published. Like there aren't enough as many standards as in other fields that have been published by organization like ISO. And the fact that if things go wrong, it's not very clear what the accountability and responsibilities should be. So if you hire the right team can come up with these things within the organization and figure out solutions around these ethical challenges. So if you are interested to learn more about the technical details of the AI and how to actually understanding a bit more about the fundamentals of AI, we do have the AI for Engineers course for anyone who wants to go more into detail of different types of machine learning and how they work. We will also be doing a data science course and data engineering course for people who have a bit of Python background, so they want to understand how they can actually build some of these models themselves. The difference between data science course is that you will focus more on the statistical and data visualization part of the modeling work, whereas a data engineering course is going to be more focused on processing the data and working with databases. All of it will require some form of Python experience. So we do have a foundation Python course coming up soon as well. So if anyone's interested in those beginner courses, they can sign up for the foundation Python course. We will be talking more about these in the future. So if you have any questions, feel free to ask in the chat about any of these courses if you're interested in them. But let's look at the data roles, responsibilities, and skills. So there is essentially different types of roles and responsibilities that are available within a data science team and an engineering organization that is useful to know and understand when it comes to hiring the right team going forward. So normally the way AI projects work, they have a life cycle that's somehow a bit different from other projects. Essentially, when you are working on an AI project, you will need to identify what kind of model you want to build. And that comes down to the problem scoping to understand what kind of prediction model you want to build from your data. Once you understand what the problem is, so for example, you want to build a prediction model that can predict surface roughness of a 3D printed component. What you need to do is to understand what patterns in the data correlate to having a worse surface roughness. So you may perform some kind of data exploration to figure out what kind of data measurements you need to collect. You do data acquisition to collect them, and then the data science team or the data team will then perform some kind of modeling iteratively. They keep going back to collect more data, figure out if those data correlate with the outputs. And then once the model is built, they perform the evaluation. So this is normally with any kind of AI projects, you go through this life cycle where you first ask, what kind of model do I need to build? If I need to build this model, what kind of data do I need? If I collect this data, does it even, where can I get that data from? And when I collect it, let's build the model. Does the model actually work the way we intended? So they go through this whole process. With more complex organizations, so as the organization gets bigger, the organizations normally have a lot of data sets that they have to sift through. And a lot of these data sets are silos sitting in spreadsheets or in different databases. So normally what needs to happen is that there needs to be a whole data engineering team that can consolidate the data into a single source of truth. So there's a whole data engineering lifecycle project that needs to happen prior to that, to perhaps extract, transform, and load this data into a single source of truth data set or database. And these people normally, these engineers normally work with like databases, they work with cloud tools, and they have a little bit of software engineering background where they can bring this data together from across a variety of file formats like videos, images, spreadsheets, databases, JSON files, CAT files, and all of that. And they can process that. And some of this data may also include geospatial information in them, like GPS data, coordinates, and clean that data as well, so that it's actually all ready for the people who will be doing the modeling to be able to work on top of that data, build Power BI dashboards, and do all sorts of insight extraction that is actually useful for the business. Because data in its raw format normally is not useful. There could be a lot of it. The information could be scattered all the way around. There could be lots of missing gaps in the data. So data engineers normally make sure that the data at the output of their work is actually of good and clean quality, that can be used by the modelers or by the people who will be doing the analysis on top of that. So these data engineers normally then work with doing a lot of data modeling and processing and storage, and coming up with the design of the databases and the architecture of the whole solution on how this data needs to be processed across the organizations. So normally organizations are a bit more complex. They have a lot of moving parts. They will need to do a bit of data engineering before they even get to the whole AI project lifecycle of building models. So if you just look at the roles that normally a data team might be working on together, a data team might consist of people who have domain expertise, but also it may consist of a couple of technical roles. You might have software engineers who can build the user interfaces and the web servers for you. You may have data engineers who will be doing the database work, who will be doing data cleaning work, processing this data, coming up with working cloud tools, working with IoT data, just making sure that the data is coming from all the sensors to a single source of truth location, and all the data at the end is all clean, ready to be analyzed and ready to be modeled on. Then you have data scientists, who are essentially engineers who have domain knowledge on the data, but also understand statistics and programming to the extent that they can build models. So these are the people who can do predictive modeling, who can visualize data to understand patterns in it. They can come up with new columns in the data, new features that could correlate better with the outputs that you're trying to build a model on top. So these kind of data scientists normally have a bit more like a statistical background, a mathematical background, and will be doing more of a innovative work when it comes to the data. And then you have data analysts who normally work in Power BI and work with a lot of BI tools to produce dashboards, so that other users across the organization can consume the insights from these dashboards to make key decisions for the business. So a data-centric team is essentially a collection of these roles working together. Now, what a lot of companies make a mistake on is they will try to hire for one person that has all of this. And like, people go into each of these roles, and each of these roles is a career on itself. You could have people who work across all of them. They are more like full stack data in the data science, data scientists or data engineers. But doesn't necessarily mean that they can do everything that you need them to do. So many companies normally advertise these roles without a full understanding of demarcation points between them, because they sound similar. There is misconceptions on these responsibilities for each role and how they interact with each other. So normally job descriptions will have unrealistic expectations of candidates at the end. And normally candidates who have the experience, so the talent, who have the experience that you actually need, will read the job description and they will just click away, because they can understand that the company doesn't understand how to run an AI project, how to run a data-centric project, just because they know that they probably will have very unrealistic expectations of them if they join the company. So it's very essential that when you write a job description and where you're trying to hire for someone, you fully understand which role you're trying to hire for and how these roles interact in order to deliver an AI project or a data-centric project. You may not always be doing AI. You may just be doing some data processing project to make sure that like everyone in your organization have access to the data and they can extract insights from it for making key decisions. So you may be just wanting a data engineer or a data analyst. You may not necessarily need a data scientist. So you can see, you can assess which ones you need depending on where your organization is at right now. If someone goes to LinkedIn right now and essentially writes down all the key skills that most companies want, you can create a mind map like this. So I did that like a while back ago. And essentially what I came up with is companies that are trying to build data-centric teams are essentially looking for a few key skills. So these skills are software engineer skills, being able to build backend servers and front-end user interfaces, being able to handle lots of millions of rows of data. So data engineers that can work with big data and IoT data, Internet of Things. People who understand deep learning frameworks, who understand statistics and algorithms around AI, so they can build custom AI models. Some consulting experience if these companies are working with clients and they are building products for other people. Maths and statistics background and soft skills, math statistics background so they can understand how these AI algorithms work. But also some other software engineering expertise around being able to build a good software, work with cloud tools, and being able to deploy and package up these applications into containers that can be deployed on any environment. So essentially, data-centric teams will have a collection of these skills depending on what the team is trying to achieve and what the requirements and the needs of the organization is. I think when it comes to building a data-centric team, where to start is a good question. Like, okay, we know all of this. How can we go ahead and start building a good team? I think a good place to look at is using a couple of frameworks that can lead your thinking process so that you can come up with some good action points from all of this understanding. One good one is this framework where you can look at your organization in terms of layers. So you can look at look at organization as 3 layers of organization layer, process layer, and technology layer, where the organization layer is how different business departments and business units interact. Process layer is essentially a set of processes that each business unit have and how these interact together to operate the whole organizational operation procedures. And then technology layer, that's essentially our tools, technologies that and people who support the process layer. And the process layer supports and interacts with the organization layer. So you can essentially look at the organization in terms of layers and understand, have an understanding of where things are not being efficient, where there is waste, where things are being duplicated, where there's a lot of manual work. And then from this, you can then come up with ideas for projects, especially where AI could be helping you. So where there is a lot of data, this data captures the information and the patterns in the work, and then maybe you can use AI, basically build a model on top of that data and patterns, so that then AI does the manual work for you, instead of individuals having to do things on their own. And from understanding these needs, then you can hire for the right talent in your organization. So I think the first step is identifying what kind of projects you can work on in your organizations, and then based on those projects, then identifying the roles that you may require and the talents that you need, and then you can hire for those talents. Another way to look at the organization as well is using a data maturity framework. So Lexitech came up with one that is quite good. So if you just look at the description of each of these levels, there are 5 levels of AI maturity. If you feel like your organization is doing everything by hand, so you're producing reports manually, there's lots of spreadsheets everywhere, you might be at level 1. If the organization has a lot of dashboards, they have spreadsheets that track spreadsheets. There's a lot of shadow data teams. There's talks about the data and AI, but essentially everything is still quite manual. You might be at level 2. If you're actually using data properly and you have dashboards that actually extract insights and everything is mostly data driven, you might be at level 3. Whereas if your organization has started doing a lot of AI work, you have you have actually established data and AI teams that help the rest of the business. You might be at a level 4, and actually, if you're a leader in the industry and your market, and AI ML is actually part of your organization culture, you might be at level 5. So you can see which level you are in at, and then measure and understand what you need to do to go to the next level, like where you are at the moment and what you need to do in order to go to the next level. A good framework to help you with that is an organizational assessment matrix, where you essentially look at your processes, the technologies you've got, the controls, the management, the data, and the people, and see where you are, whether in terms of you're lagging behind, you're just starting to work on it, or you're leading in terms of in comparison to the current market that you're in. So you can just use sticky notes and see where you are right now, and understand what you need to do, the action points across each of these layers to go to the next stage. What do we need to do on the process side to get better at things, or start leading forward in your market? How about in the technology side of things? How about in terms of like the controls and policies you've got? Well, how can management support this adoption of AI in your organization? What kind of data do you need to start gathering and measuring in order to start leading in the market? And what people do you need? What kind of roles do you need? And what kind of talents do you need to get to that stage? Once you do this, then you know what you need to do, and then you can go and hire the right people. If you don't have to hire the right people, you can train the talent internally. So this basically prevents you from hiring or investing in training without a full understanding of interactions between these roles, because you now have a better understanding of what you need and how those roles interact. You will also have a clear understanding of responsibilities of each role when it comes to building your organization up and building the team within your organization. You can actually draft job descriptions that actually is realistic and specifies the exact needs and maps to the exact needs of the team, and the candidates will have a better time visualizing how they will be fitting within the organization, within your team. You can also start looking for the right training opportunities for your team, and so that they can obtain the crucial skills they need to help you move towards the higher levels of data maturity in your organization and AI maturity. And you can also budget appropriately. So if you know that you need a more specialist role, like a data scientist, you can start thinking about putting together the right budget and the right the right expectations and the right budget, so you actually hire the talent that is perfect for your team. So you don't miss out on any talent when it comes to going forward. So hope this was quite useful for you, and you have a better understanding now of like how you can actually start implementing and thinking about building a data-centric team. If you have any more questions, feel free to post them in the chat. And if you are interested in learning more about how you can start implementing AI in your organizations, we do have a few courses that I'm delivering this year within the AI digital category. At the moment, it's within the essential engineers category, but it will have a whole category separate on itself. For those who are just getting started, AI for Engineers is a really great course to understand the whole AI landscape. For those who want to get into actually building it, and you don't know programming and you are interested in learning how to program, Foundation Python is a good course to get you started. If you've already started dabbling in Python and you dabbling in programming and you want to actually start building your own custom stuff, you just need to have an understanding of the concepts and get some experience with working with data and building some of these data science, data engineering, and AI modeling course could be relevant and interesting for you. And I think one last thing about data science and data engineering is that data science mostly focuses on the statistical part of it and mathematical part and modeling side, whereas data engineers mostly think about databases, architecting data systems, pipelining, and cleaning data, processing it, so that data scientists can have a better time when it comes to building AI models on top of things. So thank you very much. Hope you enjoyed today's webinar. If you have any questions, please feel free to post them in the chat, and then I will have a few minutes to be able to answer them.
Amazing. Thanks so much, Ali. And thank you, everyone, for your participation and listening. I've got a question in the chat here from Samil. Says, how would you recommend we get the necessary knowledge in maths and statistics, as people in this field typically have a master's or a PhD?
So the good news is you don't necessarily need a master's or a PhD in this field. So the people who go and get those are actually well placed, because they will go through a structured curriculum to have those understandings. But with anything, there is a 20-80 principle in practice. So even if you learn 20% of the knowledge that you need, you can get ahead 80% in actually building something. So there are courses online that you can take that are free, perhaps on Coursera or on various other resources, Data Camp, that can teach you these statistical components to get you started. But there is also, we will be doing a data science course that will go into those details and skills. So you just need to identify which course has the right topics for you to feel more confident and feel more empowered to get your hands dirty in this field, essentially.
Brilliant. Thanks, Ali. I've got another question here. Someone is looking for a bit of help in identifying which of the data science or data engineering courses might be right for them. How do you identify which one is the one for you?
Well, each of the data science and data engineering, so with our data science and data engineering course.
Yes, R1, sorry.
R1, yes. So data science is more about statistics. Data engineering is more about databases. So it depends on whether you are going to be doing a lot of data processing. Are you going to be taking a lot of data from a variety of file formats and processing them into a single source of truth? Data engineering courses are more relevant, and you're going to be working with Python and cloud to perform those operations. If you're more interested about data visualization and performing AI modeling and analyzing data, identifying if there is bias in the data, identifying performing descriptive statistics, inferential statistics, data science course is more relevant. Depends on where you want to go and which one is more relevant for your organization at the moment.
Brilliant. Thank you, Ella. That's really helpful. I think that's all the questions that we have at the moment. Have another quick look in the chat. Last call if anyone wants to pop a question in. Otherwise, thanks ever so much, everyone, for joining. And thank you so much, Ali. Really great presentation.
Thank you very much.
And yeah, please do get in touch if you'd like any more information on any of our courses, or if you have any questions for, oh, here we go. We've just had another question pop up at the last minute there. Omar's asked, can you please explain the difference between software engineer and data engineer, etc.?
Yeah. So this is a really good diagram to refer to when it comes to understanding the differences between the roles. So software engineers could be data engineers. So if a software engineer is working with a lot of data and building tools that process data, part of the role is becoming a data engineer. Or they may just morph their role into data engineer. Other things software engineers might do is that they may build web servers, application programming interfaces. They may build user interfaces that normal users can work with. So software engineers, to some extent, build applications. So they may not necessarily work with data. They may work with data, but they may not necessarily work with data. They may just be worried about building a server or building a user interface that interact with the server. Now, the server could be serving data, and it could be interacting with an AI model, and it could be any of those things. And those are where software engineering is useful, because if a team just has a data engineer, data scientist, and data analyst, and they don't have a software engineer, what would happen is that whatever output, whatever tool they produce is going to be too technical for most people to work with. A software engineer can come and package that tool to have a nice user interface on top, and it doesn't have any issues and any bugs, and so that the normal users can interact with it. To give you an example, ChatGPT, if anyone has used ChatGPT, is a really nice bot that you can you can log into it and talk to it, and it's just an AI model that talks to you, and it's been built by OpenAI. ChatGPT actually was around since 2018 or 2019. They released the model. It just had a really bad user interface. It was just a form input. In 2021, I think, they released a whole user interface that really looked really nice. You could easily interact with it. You could log in, interact with it. And since that user interface made it so accessible to interact with these models, that's when the whole that's where it became really popular. Just because a couple of software engineers built that tool so that non-technical users can actually start enjoying and using that tool. And if you want whatever tools you build in your organization to get adopted properly, you will also want to have a software engineer, perhaps, that can actually build a proper and software or a user interface on top, whether it is a web application or a desktop application.
Amazing. Thanks so much, Ali. I think that really is all the questions that we have now. So again, thank you so much, everyone, for your questions and participating. Thank you so much, Ali, for presenting. We've had another question just come in. Thomas would like to know any examples of energy or process industries where AI and data engineering is well established.
I think I can't think anything on top of my mind, but normally big companies within those sectors might be already doing some stuff. They may not publish it on their websites that they're doing it. What they may be doing is they might have some teams because there's a lot of people working in those organizations, and obviously some of those people will be very enthusiastic about AI and data. So they will be actually putting together their budget to build a team, build a talent, and secure the right training. It's just that they may not actually publish about it until they have done some projects or they have started to gather some information. But if you just search about it on Google, there is a good website. There are some couple of competition websites, data science competition websites, that people start doing some work in them on energy data. Kaggle.com is a good resource. I will post it in the chat, where essentially people who have the skills to build models go on there and take some data sets related to energy industry and start trying to see what they can build with it. And other people go and upload some open source data sets they have within the sector in there, and they just try to compete with each other to build the best model. So there might be some resources online that you can look at to find applications, but it's just because it's such a new area in at least in engineering, you may not easily find published case studies or published articles online compared to other industries, which is way more established in this field.
Okay, great. Another question, if that's all right. Wanda has asked, how would one as an engineer find a way to apply AI to one's field?
So I think essentially that's a really good question. I think when it comes to is understanding the fundamentals of AI and understanding how AI works. So I broke down that the fact that one type of AI is machine learning, and machine learning has different types: supervised learning, unsupervised learning, and reinforcement learning, where you can do classification, regression, and all of those things. Essentially, the best place to start is do a course that gives you enough confidence and understanding of the field, and it gives you lots of ideas then how you can implement it. So it's essentially you got to start doing a couple of courses that helps you build a knowledge base in your head and a mental model of the field, so that then you start getting ideas and building enough confidence to building something with your own data.
Okay, great. Thank you. I feel like I've said this a few times now, but I think that might be the end of the questions. I'll just give it 5 more seconds in case another one pops up.
Yeah.
No, I think that is the end of the questions now. Perfect. Brilliant. Thanks again, everyone, for attending today. Thank you so much, Ali. I've seen a few people in the chat have asked about the slides and recording. This will be posted to our YouTube channel next week. We've popped a link in there, but we will pop it in again for anyone who missed it. And yes, thank you so much, and have a great weekend. We hope to see you on one of our training courses soon.
Cheers. Thank you very much, everyone.